Now, lesson 4.1 deals with rate of change. Now, remember, the definition of rate of change is a ratio that compares the difference between two outputs to the difference between the corresponding inputs. Another definition is it's the change in the vertical axis over the change in the horizontal axis. And finally, my favorite is the change in y values versus the change in x values. So you take any two y values, you subtract them, and you put them over any two x values that correspond, and you subtract those as well. And then you finally simplify to get your rate of change. Now let's look at the first example. It deals with washing windows and the amount of money that students made. So based off the definition, you can take any two y values and take the difference, which is subtracting them, and then take those two corresponding x values and subtract those as well. So I'm going to take 225 and 180, and the difference, right, is going to be subtracting those two. And then you want to set this up as a ratio, so include your fraction bar, and then take the corresponding x values, which is 75 and 60, and subtract those. All right, my numerator is going to give me 45, and my denominator is going to give me 15. Now I want to simplify these, so I know I can divide top and bottom by 15, so I'm just going to write this here. So my numerator then becomes 3, and my denominator becomes 1. Now I can leave this as a final answer when I'm dealing with rate of change, because this is going to interpret our data, or allow us to interpret the data. So if our y's are the numerator, y represents the dollars, so we made $3, and the denominator represents the amount of windows per one window. All right, and that's how you interpret the data. Let's look at another example. This example deals with the amount of hours spent babysitting and the money earned. So again, any two y values, I'm going to take the first two I see. I'm going to take 36 and 12, and I'm going to subtract them. Now take the corresponding x values, which is 3 and 1. And I know they correspond because they're right next to each other. 36 minus 12 is going to give me 24. 3 minus 1 is going to give me 2. Now again, I want to simplify these. I'm going to divide top and bottom by 2. And that should give me a final answer of 12 over 1 for my rate of change. Now, if you leave it the way it is, this will allow you to interpret your data. So y values are going to be the money, and your x values are going to be the hours spent babysitting. So this really means $12 per 1 hour that we babysit. Okay? So we looked at tables. Now we could take a graph and find the rate of change of our graph as well. So if we don't have a table, we need to find our x's and our y's. And in order to do that, you need to find a point that's on our line that we can easily distinguish. So in this case, we picked 412 and 13. So let's see if that falls on the line. This is 13, and this is 412. Notice how they fall on the line. You could pick other points as well, like 26 or 39. It's up to you. So again, you want to take the difference between your y's and the difference between your x's. So I'm going to take 12 minus 3. That's my y value. Those are my y values. And I'm going to take 4 minus 1. 12 minus 3 gives me 9. And 4 minus 1 gives me 3. Again, you want to simplify these. Divide top and bottom by 3. And you will get a final answer of 3 over 1 for your rate of change. Now, with your graphs, you want to look at your variables. So x represents the number of ice cream sandwiches, and y represents your cost. So that would be $3 for 1 ice cream sandwich. And that's it.